Welcome to Systems of Linear Equations, lesson number 3. This is the start to solving systems of linear equations using algebra, and so we are going to focus on two methods or two algebraic approaches, and the first one we're going to look at is substitution. And so in the little flow chart here, they kind of lay out for us the type of process that we're going to take. First, we're going to try to identify in our systems of equations which one looks simpler, and when we take the simpler one, we want to try and manipulate that equation that we've identified as being the simpler one into one of the other variables. So we might say or rearrange it so it's just x equals, or rearrange it so just y equals. And once we have that manipulated, we take that equation and we actually substitute the entire expression into the first step of the other equation, and then we have an equation in one variable and we're working to solve for that single variable. And then we just want to go back once we have a solution for one variable. Remember, a system has an x equals and y equals pair, so we're going to go back and figure out what the other variable is using any of our two equations. And so it's quite difficult looking at that flow chart to try and decide what we're supposed to do, but if we do a little bit of practice, it's gonna make sense, or we can kind of talk ourselves through those steps. So here I'm looking at a system of equations. I'm seeing x plus 4y equals 17 and 2x minus y equals 7. Now together those are two equations, they form a system. I want to, in A, solve the system using substitution. That's my algebraic approach, by first rewriting the first equation, this x plus 4y equals 17, in the form x equals. So I'm just going to copy this down here. X plus 4y equals 17. And to get that into x equals, this might have been the equation you identified as simpler. Right now they're telling me which one to use, but this would be the one I say, okay, that looks pretty simple to write in terms of x, because x is already alone. So all I have to do, or x doesn't have a coefficient, I should say, is get x alone by taking away 4y. So I can say x equals 17 minus 4y. Now I take this whole thing, because that's now x, that's named x, x equals that, I take it up to this other equation. I'm just going to rewrite it for you here. This second equation, 2x minus y equals 7, I go up to that equation, and where I see x, I'm going to write this expression. So I have 2 times x. Well, x is 17 minus 4y. So 2 times 17 minus 4y. And then I just keep going. Once I've subbed in the x, you can see here, I'm going to just square that for you so you can see the replacement I made. X was 17 minus 4y. So now once I've got over the substitution, I just keep on reading my equation. Minus y equals 7. And now this is the equation now in terms of y only that I'm going to focus on rearranging, simplifying, and trying to find out what y equals. So first step I'm going to do is by order of operations brackets. So I'm going to go 2 times 17, that's 34. 2 times negative 4y, that's negative 8y. Minus y outside the brackets, that's equal to 7. I'm going to add my like terms. Negative 8 and negative 1y make a negative 9y. I'm going to leave the 34 for a second. 34 minus 9y equals 7. I'm trying to solve for y, so I want y on one side, numbers on the other. I'm going to take away 34 on each side. 7 minus 34, that would be negative 27. That's equal to my negative 9y, because 34 minus 34 goes to 0. And so now I have negative 9y equals negative 27. I want to solve for y. Dividing by negative 9 will show me that y equals 3. And so I've done a lot of algebra, and so I think we would stop here and we'd say, okay, well, y equals 3. That's my solution, but that's not the full solution. I need an XY pair. So I have to pick whichever one I want, pick which equation I think would be easier to sub in y. So it's almost a double substitution. First a substitution of x and then a substitution of y into an equation to solve for x. And so I go back up here and I'm going to choose the first one. X plus 4y equals 17. Now I know that y was 3. So I'm going to plug in 3 wherever I see a y. So now I have x plus 4 times 3 equals 17. That makes 12. So x plus 12 is 17. And if I take away the 12, x equals 5. And so when I state my solution on the side here as an ordered pair, I would say x equals 5, y equals 3, which could also be represented as the pair 5, 3. And so a lot of work with substitution around the algebra. And so sometimes we think, okay, well, does it matter if I choose x equals or y equals? And the answer is no. You can choose to rearrange in terms of x or rearrange in terms of y. However, your steps then change. So in part B here, can we solve the system using a method of substitution by rewriting the first equation in y equals? So now I'm going to take, or I want to show you, I think, let's try it with the second equation. Okay, we've already done the first equation, we've rearranged it. Let's take that second equation, write it in terms of y equals to prove that we can, can sub in y or sub in x, and we can get the same answer. So I'm going to take 2x minus y equals 7. Maybe this was back to my first step. I looked at the second equation, I decided that was the simpler one, and that was the one I wanted to write it in terms of one variable. Now I have to choose which variable. Do I want to write this in terms of x, or do I want to write it in terms of y? And because there's all 2 with the x, I really don't want to write it in terms of x. Well, I could, but I'd have to divide by the 2 eventually. So I'm going to go in terms of y. So I'm going to add y to each side so that I get 2x equals y plus 7. Here would have been the step where I could choose to divide by 2, but in fact, I want it in terms of y equals, so I'm going to take away the 7. So I get 2x minus 7 equals y. And now here's my equation in terms of y equals, and I like to sometimes draw a box around that expression to say I've just figured out that y is equal to that. I'm going to go back up to the other equation that I have not manipulated yet, x plus 4y equals 17. And wherever I see a y, I'm going to replace it with this box. So I go here and I go, okay, y was what I labeled. Draw a square around y. Rewrite this equation as it is, except for the fact, add in the expression using brackets to show that y was 2x minus 7. So I'm replacing y with 2x minus 7, and then I'm continuing on equals to 17. And so by order of operations, I'm going to do brackets first. I'm going to leave x plus 4 times 2x, 8x, 4 times negative 7, negative 28, equals to 17. You're usually going to have or you will always have an equation of one variable, but your variables you have to collect like terms. So 1x plus 8x is 9x minus 28 equals 17. I need to add 28 add 28 to 17. 28 plus 17 is 45. So now I have 9x equals 45. Last step, divide by 9. And x equals 45 divided by 9, or 5. And so I have x equals, a lot of algebra to get the x equals, but I need the other half of this pair. I need the y. So I get to choose whichever one I want. I can go back to the first one or the second one to solve for y. I'm just going to go to the second one. I'm going to say 2x minus y equals 7. It's just which one I feel like using right now. So 2x minus y equals 7. Wherever now there's an x is actually the number 5. So I'm going to almost a double substitution. 2 times 5 minus y equals 7. 10 minus y equals 7. And so let's take away the 10 to get y alone, although it's going to be negative. That's okay. Negative y equals 7 minus 10, or negative 3, which dividing by negative 1 or crossing out the negatives, y equals 3. And so I want to just take these two solutions and I just want to rewrite them somewhere down the side of the page here, or where it's really clear what my solution was. That x is 5, y is 3, the pair 5, 3, and you can see this matches what I had up above, and I've taken different routes. So I keep mentioning that this maybe refers to a double substitution, and when I say that, I'm saying, okay, pick your favorite equation from the two in the system, rewrite it in terms of x or y, your choice, sub in or substitute in, replace x or y, whichever one you chose, with your expression, solve, get a solution for x or y, and here's kind of the second substitution. Pick an equation, your choice, which one, sub in which letter you have, solve for the letter you don't have, so that you have a solution for both x and y. And so part C and D here says verify that the solution satisfies both equations. That is my checking step. I just would want to verify plugging in x or y, verifying that left side equals right side. And if I was going to graph this, I would want to write them in y equals and find the intersection. So I'm just going to leave that blank because I kind of wrote through part C at least. So this introduces the method of substitution. We're going to practice it 2 more times, I believe, on the back of the page. So let's turn there now. And again, you don't always have to take the method that I would take, but you do have to follow the steps of substitution. So consider the following system of equations in class example number 2. 4x plus 3y equals 0. 8x minus 9y equals 5. Solve and verify the system using a method of substitution. So I get to pick which one I think is simpler, and then I get to choose which variable I want to write it in terms of. So I'm looking at this, and I'm leaning towards this one being the simpler one because 4 and 3 is smaller than 8 and 9, as well as one side is 0. So I'm thinking maybe this one will be easier to deal with. So I'm going to choose that one. That's my first step. Say choose an equation. I'm going to write out your steps here for you. Okay, choose an equation. Second step, manipulate this equation that you've now chosen for one of the two variables. So manipulate for either x or y. So I'm going to choose to write this in terms of y equals, like no preference really, x equals y equals, doesn't matter. I'm just going to say, okay, let's write this in terms of y equals. And take away that 4x. So that 3y equals to negative 4x. Divide by 3. Y equals negative 4 divided by 3x. So now I have this manipulated in terms of y. Could have chosen x, similar steps. It just would have been 4/3 y rather than negative or 3/4. Yeah. So anyways, y equals is what I have. Once I have y equals, I like to draw a square around this expression that I have. And I like to go up to the equation I haven't used, find the y value, and draw a square around it. And now I know I'm going to go up to this equation, and I'm going to replace the box up here, that y, with this box down here, the negative 4/3 x. And so what that does for me is it writes an equation in terms of one variable. And we say that this is like your first substitution. Okay, so I'm going to go back up here. Here's the equation I hadn't used yet. 8x minus 9y equals 5. drawn a box around the y, replacing that y with my box down here, negative 4/3 x, just in brackets, always in case I have to share and care or whatever I have to do, and I just follow along, keep going. 8x minus 9 replaced y equals 5. I'm not changing left or right side now. And now I go ahead and simplify. So in this case, 8x, negative 9 times negative 4/3. So I might want to check that on my calculator, that negative 9 times negative 4/3 is positive 12x. That's equal to 5. And 8x and 12x are like terms. 8x and 12x would make 20x equal to 5. Solving for x, I'm going to divide by 20. X equals 5 divided by 20, or if I fraction this or write it in terms of, in simplest terms, it's going to come out to 1/4. So that's fine, fractions are allowed. X equals 1/4. Okay, so now that I have x, I want to choose any one I want, the first or the second equation. Go back, and I need to get the other half of this pair. I need to get what y is. So I'm going to go back up to my 4x plus 3y one. Let's just a choice, because I just chose this one mainly because I'm looking here and seeing 1/4, and I see 4, and I'm like, man, I wonder if that 4 and the divide by 4 would cancel out, and that's actually what's going to happen. So I'm just going to sub in here 4 times x, 4 times 1/4 plus 3 times y equals 0. So I'm solving for y. 4 times 1/4, that's 1, plus 3 times y equals 0. And then I can say I'm going to subtract the 1 so that I get 3y equals negative 1, divide by 3. Trying to get y alone, I'm going to undo that multiplication by 3. Y equals negative 1/3. And so I've got my x equals here 1/4, y equals negative 1/3. I'm just going to verify or rewrite that solution somewhere so that I can see them together, that the solution to this system is an xy pair where x is 1/4, y is negative 1/3. And so maybe what, maybe what I haven't shown is the fact that I went back to the original equation. You don't necessarily have to go back all the way to the original, and it might be easier actually. Here is x, here is y, already totally manipulated in terms of x. I could have gone right here and went negative 4/3 times 1/4, got my answer. That would have been a lot easier. So you don't necessarily have to go back to the original. I'm going to add that in step 4 here, or just clarify that would have been the easier step. And sorry, I feel like I've cut that paper off there. So if you didn't have the chance to get this algebra down, or I was writing off the side there, feel free to pause and take a minute to record that. But I'm going to go over here. Step 4, write an equation in terms of one variable. Okay, I did that. I substituted in. I solved for x. So I'm going to say solve for the one variable. Was my 4th step. And step number 5, I'm going to say go back and sub in. This is your second substitution. To solve for the other variable. To solve other variable. Okay, so you can choose to go back to the original, or you can choose to take this over to the one that you've already manipulated, assuming there was no error here, and sub it in. Okay. Let's up the difficulty level a little bit here with the substitution. Solve the system using the method of substitution. The system is actually up here. It's got 5 times bracket 2a minus 3 plus b equals 5, and 6a minus 2 bracket b minus 4 equals 20. And so both of these form a system, right? There's two equations there. However, instead of being an x and y, the only difference is they're in terms of a and b. And so when we get to the end here, we're gonna state a solution that says a equals something and b equals something instead of x equals something and y equals something. And so you get to pick which one you like better. Doesn't matter which one. Pick the first if you don't know, and try to manipulate it for one variable. So because I'm like looking here and both of these look the same, they both got brackets to deal with, they both got numbers on the other side, I'm just gonna choose the first one, sort of at random, and say, okay, I gotta work towards getting this with either A or B alone. And so I'm going to go here and share that 5. And 5 times 2a makes 10a. And 5 times negative 3 is negative 15. Plus b, whoops, I missed the other half of my equation here. That was supposed to equal 5. So I'm just going to keep following through that. That equals 5. And I have to simplify. So I'm going to write it in terms of b equals. That looks like maybe the easier thing to do here. And so that means I need to get just b equals, and I need to get everything else on the same side. So from here, I'm actually going to take away the 10a, and 10a minus 10a now would go to 0, which means I got to take away 10a over here. But I also have to get rid of the negative 15, so I'm going to add 15. And so negative 15 plus 15 goes to 0. And so on this side, I have, so right now I have a b on the left side. On the right side, I have negative 10a, and then 5 and 15, that makes 20. So negative 10a plus 20. Okay. Once I have one variable, this is where I like to draw a rectangle around my substitution. I'm going to go up to the second equation. That's 6a minus 2 bracket b minus 4 equals 20. Rewrite it for a second so we can see what's sort of going on. And wherever I see b, I'm going to replace it with this, negative 10a plus 20. So I'm copying down 6a minus 2. There's a b. That would be my replacement. Negative 10a plus 20. Once I've replaced b, then I just continue on. Minus 4 bracket equals 20. And so now I've got just algebra here to try and solve this. So it's multi-step equations most of the time, but don't feel overwhelmed by them. Start with your order of operations. Start in your brackets. Can you put anything together in your brackets? And so the answer in this case is yes, I have a positive 20 and a negative 4 that can go together. And so positive 20 and negative 4 will be positive 16. And that's equal to 20. And then the second thing is, okay, now you have brackets simplified. Deal with the brackets, usually if you have a multiplication, by sharing that coefficient out front. So leaving the 6a, negative 2 times negative 10a, a positive double negative there. Negative negative makes positive. 2 times 10 is 20a. Negative 2 times 16 is negative 32. Or minus 32, that's equal to 20. Add and subtract left to right, 6a and 20a, like terms together, 26a minus 32 equals 20. Not quite done yet. I've got to get that 32 because I want a and anything with a in it on one side. And I want numbers on the other side. So just add this 32 so this side goes to 0, which makes 20 plus 32 is 52. 26a equals 52, almost done. 26 times a, the opposite, would be divide by 26. 52 divided by 26 would be 2. And that fit nicely that now I can say, okay, right at the bottom there, A equals 2. And so I'm going to show you the substitution that I sort of missed last time. I don't necessarily have to take this A equals 2 and go back up to an original. That might take a lot of time because I got to deal with the brackets all over again. But I can take this A equals 2. I have an equation for B right here. So I'm going to say B equals -10, but A is 2 plus 20. -10 times 2, -20. Add 20. That's going to cancel out. -20 and +20 is going to be 0. And so A equals 2, B equals 0 would be my equation. I'm going to show you now just the one last, or because I haven't done it yet this lesson, how might you verify that it satisfies both equations. So I'm just going to, here's my solution. A equals 2, B equals 0. If I want to verify, check that I'm correct, because that's almost the beauty about systems of equations. You can just keep checking and checking and checking until you're for sure, 100% sure that you are correct. And so if I'm going to start verification process, I'm going to take a look at one equation and then the other. And so this is the first equation I'm choosing to look at. I'm just going to kind of almost even draw a column. And I'm trying to prove that left side equals right side. And so if A is supposed to be 2 and B is supposed to be 0, this will be 5 times 2 times 2 minus 3 plus 0. That's supposed to equal 5. 5 times, well, 2 times 2 is 4 minus 3, that's 1. 5 times 1 plus 0, that's 5. And I'm just going to carry this 5 down. Now I can see left side equals right side. So it's verified for one equation. I know for sure this solution at least works in one equation. I want to go ahead and do the verification for the second equation. Copying it down here again, 6a minus 2 times b minus 4 equals 20. And so subbing in, now I almost want to draw a chart here. That subbing in A, the number 2, B, 0, want to see if left side equals right side. 6 times 2 minus 2 times 0 minus 4, does that equal 20? 6 times 2 is 12, minus 2, 0 minus 4 is -4. Does 12 subtract 2 times -4 equal 20? Well, this is 12. -2 times -4 is +8. 12 plus 8, that makes 20. And that equals my right side. I'll make the comment left side equals right side. And so now that I've verified both equations, I could go ahead and say that this system and this solution was verified. Okay, we don't have to do the enrichment. If you're looking for a big challenge, you can go ahead and try this. It's in terms of 3 variables, but I'm going to recommend that you head to Google Classroom right now and check out what your assignment is for lesson number 3 and start working on that assignment